This is Inspiring Design, where unique innovators come together to share their knowledge, share their insight, and keep us up to date with the latest industry trends. And here's your host, Roshan Senanayak.
What's up, listeners? Today's episode, well, there's no other way to say this, but the future is here. The focus today is going to be on flying cars. Yep, you've heard it right, flying cars. And to speak about this exciting area, I have here with me the Chief Technical Officer of Pegasus, Jacky Yang. Jacky is Australia's youngest solo flight record holder at the age of 14, and since then has been a power delta wing pilot, flying helicopters, and 8 years of Formula One driving and mechanical experience. With this combo, it makes perfect sense why he's the right man for the job and now leading the way in designing and manufacturing flying cars here in Australia. So without further ado, let's get straight into it. Welcome to Inspiring Design. Thank you so much for giving up your time and tuning in from Melbourne. So this is, I think, one of the most exciting conversations, and I'm super into it. Welcome to Inspiring Design. And can we start off with a little bit of background? What's your story?
Of course, Roshan, thank you very much for having actually my first podcast. So I'm also very, very excited.
Awesome.
In terms of my background, how about let's leave that to the last, because it is something unconventional, I would say at least.
Sure.
But the story is that our founder, Michael, he was in a traffic jam one day. And then he looked up and realized there was nothing in the skies. So then he realized the potential that flying cars will be the next thing. And therefore, after a very long time now, 2009, now it's 23, almost 14 years, he decided to make the flying car. So what is behind me right now are the two Pegasus E flying cars. One of them is for the civilian version, and the other one is we want to make it for the specialty departments, like police force.
Yeah. And I have seen some of the exciting images with the police and the ambulance forces actually testing it. So I want to talk about those things and how you got there a little bit. But let's step back a little bit. And you mentioned your founder seeing that vision almost and literally starting. But tell me about flying cars. Like, what's it all about for those people who aren't aware of it? We get a lot of students excited, and mainly they think of it something as a futuristic thing. So in your expertise, what exactly is a flying car? And yeah, tell me more about it.
A flying car is what you have seen in the movies. It's supposed to drive and supposed to fly. And I think at Pegasus, we do something a little bit unconventional in terms of that Pegasus does fly and does drive, which is very different to what a lot of the market has been talking about, eVTOLs, for example. They're more of an aircraft that can do vertical takeoff and landing and are designed to take you to a vertiport, which will be the infrastructure for those eVTOL aircrafts. But we believe a flying car, by the very definition, should be what exactly like the movies are. And this is also why we picked the engineering approach that we have decided, which is a combination between a sports car, we like to say, and also a rotorcraft, which allows us to do vertical takeoff and landing, and anytime, anywhere. This is our approach. So yeah, flying cars are definitely the next thing. And the reason for that is because the airspace is a resource that has not been utilized for daily transportation. And your traffic condition is not getting better in the morning, and that is the truth.
Yeah, 100%. And I think tell me a little bit more about exactly that. Now, I'm familiar with your thought process, but for the listeners, I understand that the traffics and the scalability of roads, it's not possible at the speed that the population is increased. The way we need to move and travel, it doesn't work the way it needs to. And planes is really far high up, and I believe the space you're playing with is in between. So how does that actually determine how that's operated? Like, what's the process behind that?
So Pegasus, we have designed something that works under current airspace regulation. So whatever the airspace that your license is subject to, this is where you can fly. I mean, this is talking about early adoption, of course, because it's not possible to build a fully functional network right now. But the good news is that FAA or CASA even has a plan for how these network will look like. Essentially, there will be quite a lot of altitude separation. So because we're in three-dimensional, someone can travel at 1,000 feet, and another line of vehicles can travel at 1,200 feet. Essentially, these kind of separations allow us to have a great number of flying cars. And because, again, airspace is extremely large, much larger compared to those even six-lane roads, and therefore the possibility for those flying cars to operate is extremely sufficient, and it's also very operatable. So this is how it's going to be. Of course, later on there will be fully autonomous versions, which many people are going for right now. So it takes out that human factor, human errors most of the time, and so yeah, aviation is obviously extremely safe, much safer than cars. So yeah, it's exciting.
And has that space been actually defined? Like, for example, I think if I'm referencing back to an episode prior, is anything above 10,000 is considered the aerospace, or beyond the atmosphere is the space component. Or do you have the definition for your sector yet, or is that something still undefined?
I'm sure the definition will improve later on, but under current airspace regulation, what we say is that populated area, you must fly at 1,000 feet or above. And on approach for rotorcraft, you can do about 700 feet. So this is the separation that we have right now. Again, this is conventional airspace regulation, nothing special yet. But because in terms of adoption, we can picture 30 of those flying cars in the Melbourne airspace extremely easily. There are more than 30 aircrafts flying at a time right now. Adding another 30, even 100, there's no issue with that. So the current airspace regulation actually gives us, especially Pegasus, the flexibility to test out these flying cars. And later on, again, definition will improve. I'm sure the separation will be very different to today.
Perfect. And I believe you're one of the only company that might be actually operating in this space in Australia. Is that correct, or are there other competitors in this part of the world?
Well, Pegasus is the world's only flying car that can do vertical takeoff and landing, but also rollable. So this is what makes Pegasus special. But as a flying car concept or VTOL, eVTOL concept, there are a few other companies doing so in Australia too. But yeah, so they're quite different in terms of they use battery technology. They use electric drives. Again, as much as electricity will be the future of aviation, but it is not good enough right now. And this is actually a special point about Pegasus because we use a hybrid system. So we fly with 98 petrol, which is accessible everywhere, but we drive with electricity on the road. That makes us practical in today.
Absolutely. And I think I can just imagine the sheer number of engineering thought processes that you're actually marrying together. So that's really interesting. But before we actually get to the skills, I want to almost forecast where you think this sector is going to go. It's very exciting for teachers listening in and students listening in as well to understand what the future looks like. And you're, I think, one of the pioneers always looking into the future and paving a new pathway. In your opinion, what do you think this sector will look like in the next maybe 5 years? And where do you think it'll be by the time we, maybe reach 2040, 2045?
Yeah, the market as a whole will have very early adoption in the next 5 years, and even including those eVTOLs, I believe. But I think the operation will be quite limited, and especially their speed will be quite limited because of the way they fly, especially some of them are fully autonomous, which I think as much as I trust these technology very much so, but I think as taking passengers around, you will still need some sort of a pilot in there. 2032 is a good year because the Queensland government actually released some of the a white paper saying they want flying taxis to be taking passengers as transportation to the Brisbane Olympics. So that is happening for Australia, but I'm sure other technologies, even other companies that are doing flying cars or eVTOLs, they will start to push these products trials onto the market, and that's certainly globally. Australia is actually a very good spot to start. I mean, I'm sure everyone remembers that Uber wanted to start a network probably 3 or 4 years ago now. Unfortunately, it didn't happen, but obviously they become a combination with Joby and other companies like that. So, this is still happening. But again, because airspace is a resource we have not yet utilized, so it is destined to happen. And 2040, Morgan Stanley predicts that the market will be $1 trillion globally. So that is not a joke.
Yeah,
it is going to be big.
There you go. There are a lot of career opportunities there, and talk of the town. Obviously, whenever someone thinks about technology right now is AI. Do you have any plans or any AI integrated with your system? Because I think even the fact that you mentioned the Uber context, there was a lot of public concern of, do we really want to get in something like a autonomous vehicle or a flying car that's actually manned by AI? It's a very scary thought for a regular person, or even, it's almost beyond this world. What are your thoughts on it? And do you think that AI is going to integrate with yours?
The answer is going to be yes. It has to be. But what level of AI we're talking about, that will be how the decision will be made.
Fair. Yeah.
That is the future, unfortunately. So certainly, yeah, integration with AI is going to happen, but it's going to be depending on whether they're going to be making decisions about the simple flight path. I mean that's something they can do quite easily and perhaps better than human beings already. But in terms of when in a given situation, just in case if something fails, how they can be programmed or how can they be educated, taught to make a decision. I think that is some way to go, but again, that is certainly happening. But Pegasus will certainly do something because we hope to push out a 4-seater air taxi by the end of the year, actually.
Awesome.
And later on, that particular model will also be autonomous.
Yeah.
So yeah.
Fair.
But as early adoption, I'm sure there will be a pilot in there. But later on, only the passengers will need to go into the vehicle.
Absolutely. And I think that's a smart approach as well. And I didn't mean to put you on the spot. It's just simply because our previous episode that we just launched was also about AI, and it's very relevant, a common question. That's why I thought I'd ask that one. But one of the things I really want to understand is the engineering and the thought process, because drawing connections to skills and those types of career pathways is where the exciting, I think, comes through for everyday people, even the listeners mainly as well. And when you're thinking about the skill sets, now I understand when you're driving on the road, there's actually still a steering wheel, it's familiar, but then that actually retracts if they're taking off. Tell me a little bit about that mechanism, because I think firstly understanding the visuals, then let's break it down into what are the skills behind that you've done to achieve that.
Okay. My principle is that if it's a complicated system, it's not a good system. It's in everything that we do. And we have a patent for our pedal box, essentially. So what we know is with a rotorcraft, you need the left pedal and the right pedal to do yaw. But on driving, you have two pedals usually with an automatic car. That the right pedal is throttle and the left pedal is the brake. So it was a very simple thing for us to do in terms of if we just want to put these two systems together, a switchable system or whatever. But it makes the entire package complicated. So we decided, well, we can actually use the right pedal, the right yaw pedal, also as the throttle when it's on the ground. So therefore, we only have 3 pedals, but we can achieve 2 sets of controls. So a simplified control system at the end of the day, but it's also extremely practical. The steering wheel, yes, essentially you press the button and the steering wheel gets stowed away. And you press it again, it gets extended out. And the reason is because the cyclic control that's between your legs, you don't want it to accidentally bump into the steering wheel when you're in flight. It becomes very dangerous. Therefore, we stow away the steering wheel, and then there's no safety issue there. It's a complete separation between the drive component and the flight component. And again, this is all about safety. And also the cyclic is also retractable. So when you're driving, you can hide the stick between your legs and it just drive normally. So Pegasus is about a design that is very familiar to both helicopter pilots, but also very familiar to everyday drivers. And that is important as a product that you want to put into the market.
Yeah, absolutely. So does that mean when it is mainstream, obviously, then the person behind the wheel and so to say, the cockpit, even they need a driver's license as well as a helicopter license?
Yeah, that's right. So obviously, but the minimum requirement for flying is you need a recreational helicopter license. That's 25 hours training.
Yeah.
So not at all at all. And it's also important because as we push the four-seater into the market, there's already a skill set in the current workforce that can work for Pegasus. Instead of training another 200 pilots to fly eVTOLs, even as a secondary pilot, it will become difficult. But Pegasus, as we go into the market, the workforce is there already.
Perfect. And so who are the minds behind that achieved what you've done to date, bringing these two sectors together, paving the pathway? What kind of engineers did you have on board, the designers? What are the career pathways almost that people can aim for right now? And what kind of career paths do you think will be available in future?
You see, I got very lucky. I got to meet Peter Schleifer. He's a mentor of mine, but he's also the automotive engineer for Pegasus. He's I would say, a legendary VA supercar designer. The trophies in his house is incredible. So he has very practical, but also advanced skill sets in terms of when he designed the road going parts of it. But actually, motor racing is many times is the front end of technology. So therefore, we were able to implement a lot of his knowledge into a new package and make Pegasus flying car extremely easy to build, but also extremely light. With me, it is 436 kilograms, which is incredible. It's not seen anywhere else. So aerospace engineers, of course, composite engineers, we have used pretty much every single set of manufacturing method there is, subtractive, additive, composite materials, really a bit of everything. But it is the mindset that is important. It's about innovation. Innovation comes from when you challenge the old way of doing things, and you must have that mindset to go forward, no matter what your position might be. I think it's important that you look at a particular task and not only complete it, but say, hey, next time, how can I do it better? That's important.
Absolutely. And I think that word you mentioned there, innovation, innovative thinking, another way of saying it is creative problem solving, critical thinking. Those are the words that resonate with the educators and students listening in, that aligns with the current education system. I call it design thinking. It's very applicable to the context. It goes hand in hand, especially when you're doing something amazing like what you're doing, and bringing these, amazing, almost very difficult things and making it into a one context. The sheer number of problems that you have to work through one at a time is the way I see this, and please correct me if I'm wrong, is it's a combination of STEM skills, the science, technologies, engineering, mathematics, combined with design thinking almost. It's the creative thinking, the problem solving, the resistance, the empathy, resilience, all of that going hand in hand. What are your thoughts when you hear that?
Yeah, absolutely. There's no denying. This is, at the end of the day, it's all about physics and math and technology, I suppose. So it is a combination of absolutely everything. But it is also very important that the package at the end of the day has to be correct, because a lot of engineers, they focus on one component and say, hey, this is perfect. But the best product at the end of the day is that a complete package. So do not only think about one aspect. Look at the bigger picture. I know it is actually very hard for many engineers to do that because most of the time they're given one particular task. But I think try to think outside the box.
Absolutely, and I think that adds music to my ears. So I'm very happy to hear when you say things like that. And when you're looking at, I think, the foundational pathways that people can aim for, if they're excited about working in their EV area in future, what do you think they should be doing if they're in school now? Where do you think they should be looking at? What do you think they should be doing to enter this exciting industry?
In high school, I'm not so sure exactly what you can do, but obviously when you go into university, there are aerospace engineering degrees that you can complete. But try to build things of your own. Even with planks of wood, see what you can come up with. Get to know the tools, and that is very important. And also ask teachers if there are particular projects you can start to complete much earlier in your high school days. And yeah, really start with Legos, for example. Uh, my aspiration, the foundation of my love for engineering actually started from my mother purchased me Legos when I was a kid.
There you go.
That is how I started. So really put your hands into work, and I think that will become very important.
Awesome, awesome. Well, look, taking this into another tangent is the technology, and always, you're almost building a new type of technology, but it is a combination of these other ones that you're bringing into fruition together. You already mentioned some of the advanced manufacturing techniques like additive and subtractive and whatnot. What are the technologies that you've implemented behind the scenes to achieve what you've done? Things like does VR, AR come into play? Do you have, obviously you would be having some form of CAD modeling. What kind of softwares do you use? Just to help the listeners understand the tools that help them bring these kinds of things to life. What are your thoughts? What are the technologies behind there?
AR, VRs, no, not really, not yet. But seriously, CAD, SolidWorks is something that we use quite frequently. And you see, again, this is something from my mentor. One thing he told me is to think in 3D space. This is a few things that not many people are able to do. I realized even for certified engineers or people with perfect PhDs and many years of so-called experience. So thinking 3D space, especially if you're doing aerospace or mechanical engineering. And again, it's all about practice at the end of the day, how you can turn that particular drawing in your mind and onto the computer software. Technology-wise, to be honest, as much as we use every single method possible, but it starts with the thought. So think how you can turn that thought into a reality. I think I must say something not very similar to other people, but I think starting from the thought and turn that into the first drawing is the most important.
I think what you just said there about the fact that you should think in 3D, it's almost, when you think about that statement, it's a no-brainer, because we live in 3D, we see in 3D, we operate in 3D. It makes sense to think in 3D, but somewhere along the lines we tend to get bogged down in 2D. So that's really valuable advice to put perspectives into play. So I really enjoy that. Now, what's your advice for educators? Because for educators, they have a tough job. They have to show these kinds of exciting career pathways and connect it back to STEM and design thinking and mathematics and English and all these things. What do you think they should be doing? And obviously, I think you mentioned a good insight there of getting students to do hands-on building things, getting them on the softwares and modeling things and thinking 3D and whatnot. Do you have any other advice for the educators to tackle and build towards these things? It's a tough one. It always gets people. So
there are teachers. I'm not so sure if I'm in a position to say anything to them, but one very important thing is they have a decision to make. They either become a method of transforming or transferring information, or they can choose to inspire or teach. I think that is the biggest difference, especially for my life too. I've been very lucky to have many great teachers. So to inspire and teach is certainly the way to go. And don't just teach them the method, tell them the potential outcome, tell them how it may change things for other people's lives. And therefore the method becomes important, and therefore the outcome becomes important. And I'm sure they know much more than me, but this is the only thing I can contribute to this particular question, I believe.
No, that's, I think, a very valuable insight that you shared there, and it resonates quite a lot with, it's that facilitation role rather than just trying to regurgitate content, or getting them to think and problem solve. So you're definitely adding to every other speaker that's been on my podcast. So don't feel bad. Don't feel bad that you're not contributing. Absolutely, nail on the head, actually, I think. And when you mentioned, you had some good teachers, and that's a statement that I always share as well. I was very lucky to have some good educators and went through the schooling system in Australia. What's been your story? Can you tell us a little bit? Because I think you have a very unique mind that I think the listeners can learn quite a bit from.
So a little bit about my background. I actually went to university for politics. Essentially, I have 2 degrees in politics. But the flying cars you see behind me, I built it with the team. I really, I was not sitting by the side saying, hey, you do this.
Yeah.
I was holding every bolt and nut, every washer possible, every composite panel possible, so we can build this together. So I have hands-on skills.
Mhm.
And again, it started with Legos from my mother. But I was also aspired to get a pilot's license when I was 14 by my father. So when I was 14 years old, I was actually the youngest to fly solo on a microlight in Australia, I believe.
Wow.
So this is also where my love for aviation comes from. I raced go-karts, so not those go-karts you can rent, but proper racing in go-karts. I also raced bikes. So this is where my knowledge of engineering came from. But as I was racing, what interested me the more was that how and why my time was improving. Not only that I was getting comfortable with the car, but the suspension setup, but the tire pressure, but how stiff the chassis needs to be, so the feedback from the road can make perfect contact with the tires. So by thinking in that particular method, got me interested and gave me the knowledge. And also when I was in university, I broke a fuel tank essentially, and I tried to fix it with carbon fiber by myself. So these kind of skills just added up, and then I'm lucky enough to convert those. So
I think you've been in training like your whole life leading up to this what you're doing now. That's incredible. I honestly love that, hearing that story, because a lot of schools actually have racing car building and racing programs and competitions and whatnot. So that's really, I think, valuable to know that these are the types of skill sets and thinking that translates onto these exciting careers. You've obviously combined it with an entrepreneurial component and pushing the boundaries and leading the pathway. So really appreciate that. Last but not least, what's your advice for students? You've already mentioned a few things. If they're, you mentioned it's going to be $1 trillion industry, and that's within our lifetime. What's your advice for them if they want to get into this flying cars industry?
That is the most difficult question. That's for sure. I think for students or graduates that's going into a new job, even a new industry, you must learn from people around you. Observe what they do, and see how you can learn from them. So your action, your performance, can be as close to their perfection as possible. But more importantly, it is critical for you to monitor their imperfections, their flaws. So your actions can be as far away from their imperfection as possible. And that's how you stand out from the crowd. For engineers, it's never enough to learn from books and paper. That's probably my advice, because until you put a piece of material in your hand, like stretch it, bend it, yank on it if you have to, and feel its temper, feel its characteristic, that is absolutely important to a career and to the future. So, but if you want to start your own company, learn how to make a judgment. Learn how to be outrageous with your ideas. Only then, you have the energy, you have the potential. That's how you do it. I think
Absolutely. So. And you're leading by example, so I really love that. And then speaking of learning from others, if they do want to get in touch with you or connect with you, learn more about Pegasus, what's the best way?
LinkedIn, that's for sure. This is actually something new for me, but I'm getting used to it. So yeah, my LinkedIn is fine.
Perfect. I will make sure that their LinkedIn is added onto the show notes. And so it's been a pleasure, man. And I always want to wrap up the episode with a mystery question. And
Sure.
I'm kind of thinking the whole episode what I should be asking you. And I think I have what I want to put in front of you. It's if you could change one thing in people's mindset about flying cars, what would it be?
Aviation is so much safer than any type of road transportation, and that's a fact. Especially in the last decade, we almost have no accidents. Almost. I'm saying almost having no accidents, and this is why also flying cars will be extremely safe. So as much as adoption would take time, but do not picture 50,000 flying cars in the air and say no. Picture 10 of them first. Picture 100 of them first. And then, as how we have been since the Industrial Revolution, we make things better, right? We build networks that becomes better. So flying cars is definitely the next thing that's coming, and you will be in a flying car no time soon, going to your destination.
Yeah, there you go. You heard it here first. Make sure you're open to the idea of being in a flying car and actually enjoying it. Maybe it's another way of safer travel. So really appreciate your thought process, insights, and paving the path in this really cool industry. Thank you so much. I'm sure the listeners got a lot out of it. Do connect with Jacky and learn more about this exciting field. Thank you for giving up your time. Really appreciate it.
Thank you, Roshan. Thank you very much for having me.
Pleasure.
That's it for today's episode. Now it's time to take action and build on the learnings to get inspired. First up, jump onto roshansenanayake.com/podcast and check out the show notes, links, and other relevant learning materials from this amazing episode. Next, if you learned something new today, click that subscribe button and set yourself up to receive live notifications on future episodes, as well as more opportunities to learn from our amazing guests, brands, and speakers. Last but not least, it's time to have your say. Join the conversation and share your thoughts and feedback on today's episode with a review, all while joining many others with a 5-star rating for Inspiring Design with Roshan Senanayake. Till next time.